Assalamualaikum and hi everyone. My name is Ayunni Maisarah Rajamuddin. I'm from UiTM Shah and major in CSC520 Bachelor of Computer Science in Multimedia Computing. My purpose in making this video to introduce and explain to you about my innovative project entitled the Dining Philosophers Problem. I hope you can understand the concept of dining philosophers even if you are not a computer science student. So my animation will explain to you about the Dining Philosophers Problem. So let's start it.
The Dining Philosopher's Problem is a classic synchronization and concurrency problem in computer science, often used to illustrate issues and solutions related to resource sharing and deadlock. Next, let's see overview of the Dining Philosopher's Problem. Imagine 5 philosophers sitting around a circular dining table. In front of each philosopher, there is a plate of rice and a chopstick. The philosophers have two conditions. They eat and they thinking. For the thinking state, only think and don't interact with any others, just mind their own business and they think, and when they are hungry, they will try to eat. For the eating state, they need to make use of this chopstick that are there placed adjacent to them. So this is a problem statement. Make sure that no two philosophers that are adjacent to each other try to eat at the same time. As you can see, a philosopher 1 is hungry and she wants to eat and she used 2 chopsticks. But philosopher 2 is also hungry and he also wants to eat. But there's only 1 chopstick available. So this is a called deadlock. Next, this is a problem in the operating system. We have 2 problems, which is a deadlock and starvation. Deadlock is occurs when all philosophers pick up the chopstick on their left simultaneously and then wait for the chopstick on the right, which is held by their neighbor. None of them can eat, leading to a situation where all process to be eat. Next, starvation. A philosopher might repeatedly be unable to acquire both chopstick and hence starve, as they never get a chance to eat. Alternative that can be used to solve this problem, which is solution using semaphore or monitors. But in my video, I'll be using monitors method to solve this problem because monitor solution better than a semaphore. When philosopher finish eating, he will go to the thinking state, and then for the philosopher at his left and right, this test function are run again so that if they want to eat, they will be able to eat. This will continue happen to philosopher 3, 4 and philosopher 5 and it will not lead to a deadlock. In monitor solution, when a philosopher is hungry first, the test is made to check if the left and right chopstick are available or not, and only after that, the philosopher will be allowed to eat. And after he finish eating, we are testing for the other philosophers on his left and right, if they are hungry or not. If test philosopher do not hungry, then it will move to other philosophers. One process will be allowed in a monitor at a time, so when one process is executing, all these other processes will be allowed to enter this monitor. Hence, we see that this is a deadlock-free solution. How about starvation? When does starvation happen? Example, philosophers 5 always want to eat and don't give a philosophers 4 a chance to eat first. And philosophers 4 will wait a long time and died because no one wants to give a philosopher 4 a chance to eat.